That's what math.
Yes.
It was a struggle that we thought we would have to
Okay,
go
we're
through.
gonna go over problems.
Yeah. I think this
Wait, is
was
it recording?
Chain rule, yes.
I did
Sorry,
like 8 problems.
I
I did 8 problems in like took me a whole period.
Now, the chain rule is one of the most important rules in calculus, so you have to get proficient in this. And you're not gonna get proficient by just loafing around.
Put loafing around there.
Because every time on the next test is pretty much technique, taking derivatives. So if you can't do the chain rule, the product rule, the quotient rule, there's going to be a plethora of fatal errors.
How is this past
Okay,
tense?
why is it in different colors?
Where's the trash
I
can?
can't see. I have no
Okay, number 9.
Scatter plot.
Say what, girlfriend?
Scatter plots?
Scatter plot.
That's why I sat with the
Matrix?
trash in the test.
Synthetic?
Truth table.
Okay, so it says compute the velocity. Well, if they give you the position equation, how do you get velocity? You take the derivative, right? Now, of course, that independent variable when we're doing this kind of problem is t, right? Time. So what do you see? I see cosine box. What's the derivative of cosine box? Is it just negative sine box?
Yeah.
No, because I left the space for the derivative of box. Now you gotta multiply by the derivative of the box, which is?
3.
Negative 3. And then I think you guys can, a negative times a negative equals a positive. Say it. Negative times a negative equals a positive.
Again.
Oh, it's from the movie.
I'll finally catch on.
Wait, what movie?
My
Tran?
To stand in the
Wait, what if you like did the cosine power 2 cosine 3t
Oh, district.
plus yeah.
What if,
Oh, no, I didn't say that. I didn't say that.
what if we change
Okay,
the size?
if you did that, okay, wait. So Tran said, apply the trig identity to this, cosine of the first, cosine of the second, plus sine of the first, sine of the second. And you will get, wait, Olga, reduction formula. There you go. Did you get sine 3t?
What just happened?
Yeah.
Oh, and therefore, if you take
What
the
is reduction
derivative,
formula?
you will get cosine 3t times the
Replace.
derivative of 3t, which is 3. But that's the same thing.
Huh?
It's
Oh,
the same thing.
yeah.
That is.
Because sine of pi over 2 minus x
Oh, yeah.
is cosine x. So yes, there are different ways of doing the problem. As long as it's mathematically correct, you'll be fine. But see, the thing is, in calculus, why do you want to even do that identity? Because we know how to take the derivative of cosine box, right? Just go negative sine box times the derivative of box. That's the easiest thing to do. 11. Position equals 4 over 3 pi sine box plus 4 over 5 pi cosine box. So, velocity, this is a constant. Throw it on the side like an unwanted pet. The derivative of sine box is cosine box times the derivative of box.
3.
Plus, this is a constant. Throw it on the side like an unwanted pet. The derivative of cosine box is negative sine box times the derivative of box, which is 5. Daga, daga, daga.
Factor out.
If you want to factor out a 4 pi, you can. You don't have 4 over. 21. That was strange.
21.
And 21, even stranger. 21. Y equals sine squared box. Okay, now I told you before, whenever you have a trig function to a power, rewrite it like that. Are you guys doing that?
Yes.
Because then now you can clearly see you have box squared.
Oh, 2 box.
So what is the derivative of box squared?
2 box.
2 box to the first. Okay, so here's the box. Times the derivative of the box. Now you gotta look at what's inside the box. What do you see? Sine box.
Oh!
What's the derivative of sine box? Cosine box times the derivative of that box, which is 3.
Which box is the real box?
So this, no, you just have box within box. Come on, we're BC, we should be able to
when
have
you
that.
box the answer.
Now, of course, now if you want to, you can just put the 3 in the front with the 2 and get a 6, or you can impress me and do this. 3 times sine of 6x minus 4. Ha ha! Double angle identity.
Oh.
Remember, 2 sine theta cosine theta is sine 2 theta.
Oh.
Or you can just put the 3 in the front and put a 6. It's good one. You don't have to impress me. Because if you try and impress me, but you really don't, you just depress me.
Wise words.
43. Oh, we have parametric equation there. X equals secant squared t minus 1. Y equals tangent t. It says compute the value of the tangent line at the given value t. So remember what we talked about last time? You can treat it like fractions. dy dx is equal to dy dt over dx dt, right? Treat it like everyday fractions. Because right, the dt's cancel out and you get dy over dx. So here is x. Now, do you want to compute the derivative of that, or you want to go use somebody?
Use somebody.
That's an identity. Secant squared minus 1 is tangent squared, isn't it?
We.
Yes or no?
We.
Okay. And again, when you have a trig function to a power, write it like that. So, we got to do dy dt. So here's y. If this is y, what is dy dt? The derivative with respect to t. Secant squared t. Let's do it like that. And then dx dt is, if this is x right here, what is the derivative of x with respect to t? Well, I see box squared. 2 box to the first times the derivative of box.
Secant
Secant
squared.
squared t. Hey! Cancel. And so you get 1 over 2 tangent t,
Well, that's the
or do
same
you want to go cotangent t over 2? No, I don't like cotangent, Mr. Park. Okay, what do we have to compute this at? It says, find the slope of the tangent line at the given value of t. What's the value of t in the problem? Negative, it says negative pi over 4. Okay, so all you have to do is plug in. Now you tell me, do you guys like tangent or cotangent better?
Tangent.
Okay, tangent. What is the tangent? So the slope of the tangent line will be 1 over 2 times the tangent of negative pi over 4.
-1.
Negative 1. So the slope of the tangent line is negative half.
Bam. Song. Where's the song?
Where is Roy when you need it?
Okay, where are we now? Oh gosh, I'm at 47. 47. This is the same thing except different. X equals, hey, I'm gonna call on somebody at random. You guys better have the right answer.
No.
T equal pi over 2. Now, these parametric equations, we did this in PCH last year. Now look at these parametric equations.
Squared.
What is the path traced out by the particle? Okay, let me call on somebody at random. Lambachane.
Yes.
It's a
Like circle,
It's a
hyperbola.
ellipse.
No,
It's a hyperbola.
no,
It's a
circle. No,
It's a
no.
None.
Undefined.
N-U-N?
Yeah.
No.
Color.
Okay, you guys don't even remember the name, remember? Okay, if you have a circle,
Oh, it's the thing.
and here's point P.
No.
If you roll the circle on a straight line without slipping, the path traced out by this.
Hyperbola.
Wait, come on.
Maybe Ramanujam.
What do we call this shape? Yoshida?
Wait, is that a hypocycle?
Wong.
Oh, redeem yourself.
Wait.
It's called a
Semicircle.
cycloid.
Oh, wait a minute. The ones on the
Like
inside
a
and the
cycle.
outside.
Yes or no? You learned about this?
No, it
PCH! It's in my worksheet.
Yeah.
I put things on my worksheet still so that you learn mathematics. Now, one of the interesting things about the cycloid, in fact, I remember when I taught it to you guys last year, you said, oh yeah, Mr. Rubash taught it, said that.
We didn't even have Rubash.
If you turn the cycloid upside down, if you turn the cycloid, like what if you had to build,
It's a catenary.
It's the
no.
Wait, isn't it the
That's
optimal?
What if you had to, okay, this is your job as an engineer. You have to build something that's, I'm gonna take like a ball bearing, I wanna move it from this point to this point. Under the influence of gravity, what kind of ramp should I build so that it'll get from there to there in the fastest amount of time?
Semicircle.
No, not a semicircle, the inverted cycloid, because at the very beginning, it's like a vertical drop and you go, whang! Because some of you would just put a piece of wood like that, but that's not gonna be the fastest because it's gonna have to accelerate to get there. It's way faster. You got the inverted cycloid. And another property of the inverted cycloid is, let's say you have a marble over here and you have a marble there. Release it at the same time. What gets to the bottom fastest?
Same
You
thing.
get there at the same time. Does that sound familiar from PCH?
Yeah.
And since Yoshida mentioned the other cycloids,
Inside.
what if you have a circle and you have another circle that's 1/4 the radius of this circle? Let's call this point P. If I roll the smaller circle inside the bigger circle without slipping, what is the path traced out by point P?
The star.
What? It was on the PCH worksheet, it said what it was.
It's a dragon.
Okay, now is the time.
Wait,
Hypocyte.
A hypocycloid of 4 cusps.
It's not.
4 cusps.
Hypo. Doesn't that make sense?
If only you was here.
Hypodermic needle goes under the skin.
Pus comes out.
It's a must.
Okay, now what if you have a circle 1/4 the radius of the bigger one and you roll it without slipping on the outside of the circle? Then you get something that looks like this. What is that? That's called an epicycloid.
Because on the
Yoshida,
outside,
Yoshida, good hero.
Epidermis, there you go.
No.
For real, come on. PCH. I told you guys, if you guys just remember everything I taught you in PCH, you would just dominate everything in life.
Even English?
Even English.
English.
I said
Even cooking.
Yeah.
Oh,
No fortune
okay,
cookie.
wait,
Ah,
we gotta do this
no
problem.
fortune cookie.
So, okay, here's the cycloid. So the particle is traveling. We haven't even got to do this problem. So it's on the side. Now, when t is pi over 3, okay, so this is 0. When does it get here?
I don't
Just
know.
looking at these equations.
1.
When will the y coordinate be 0 again?
1. No.
2 pi.
2 pi. So pi is there. Pi over 2. Pi over 3 is somewhere over here then. So when t is pi over 3, we're trying to find the slope of the tangent line. That's what we're doing in this problem. No, I'm serious, people. If you can remember PCH logic, for example, then when you take, if you're gonna go to law school, then the LSAT, if you can remember your logic, it's easy. Because there's so many times you gotta contrapositivize the thing.
Oh, just look at your video from Mr. Parkman.
Yeah, but you guys don't.
We'll subscribe.
Smash that.
Okay, so here we go. To compute the slope of the tangent line, using the chain rule, that's dy dt over dx dt. Okay, now look at the y equation. Okay, let me call on somebody over here. Hanaman, what is dy dt?
Chain roll.
No, you're just shouting out random things. No, look at this.
Okay.
What is dy dt, the derivative of y with respect to time?
Side.
Sine t, that's right.
Okay.
And then, here is the x equation. What is dx dt? Who we won?
1 1 right.
Okay, when you take the AP exam, I'm gonna look over your shoulder and go, "Urgh!" You just have to know. 1 minus cosine t.
That is so funny.
Hey, wait, hold on. A.
Yusabare
Yusabare Ishihara.
Wait, never mind.
Now,
Hey,
in
wait.
BC calculus, you're expected to
10
know.
x over 2.
Yeah.
No, that's the
No.
reciprocal of that's cotangent x over 2.
Ooh.
Oh yeah.
Hey, no, tangent theta over 2 is equal to 1 minus cosine over sine, right? Reciprocatize both sides, that's cotangent x over 2.
Oh.
We're in BC, people.
That's the
AB, I just cross out the half angle formulas for them. But we're BC. No, for real, you gotta know half angle, but in this one you don't need to know. Just plug in pi over 3 and nobody will get it. Plug in pi over 3. Root 3 over 2. Plug in pi over 3.
Half.
1/2. Multiply top and bottom by 2. Root 3 over 2 minus 1. Root 3.
Box the.
All of it's about the
That's the answer.
Okay, there you go. Okay, next we got problem 51. There we go, chain rule. We have problems with the chain rule. S equals cosine theta. Compute dx dt, ds dt, when theta equals 3 pi over 2 and d theta dt equals 5. Okay, remember the other form of the chain rule I showed you? ds dt is equal to ds. Now, you can use whatever variable you want. Now, what variable do you think we're probably going to use in this problem? Since
What?
it's
D theta.
yeah, d theta times d theta dt, because you can treat it like fractions, cancel out the d theta.
dt ds.
So here we go. If this is s in terms of theta, what is ds d theta? Ishihara, redeem yourself.
Negative sine theta.
Okay. Times d theta dt. Right. Now, they want you to compute this when theta is 3 pi over 2. So what happens when I plug in 3 pi over 2 there?
-1.
-1. And d theta dt is given 5. A negative times a negative equals a positive, so the answer is 5.
A negative times.
Why does it?
53.
Because you got the two lines.
53. What is the largest value possible for this? Come on, this is an insult to your loins, this problem.
Loins?
What?
Okay, it says, what is the largest possible value for the slope of this graph? Now, how do you compute slope? Compute the derivative. So dy dx is ui2. Sine box, so
Square root.
what?
Oh.
No half-angle identities.
Oh.
Just go, what's the derivative of sine box?
Oh, cosine x over 2
You just say cosine.
times 1.
Very good, that's it. Now they're asking, what is the biggest this will ever be? Well, what's the biggest cosine ever gets?
1.
So therefore, what's the biggest this will ever be?
Half.
1/2, finish.
Box that.
Right? The biggest cosine and sine ever gets is 1. See, maybe that problem was too simple for you. You guys are thinking up here when you should have been thinking down there.
Where my stock is.
No, your stock is like downstairs.
Wait, it was like right there yesterday.
Underground. What's right below this? Seton Hall right below this? Or classrooms? Okay, so dig 5 meters under that. You need to be somewhere there. Find the lines. Come on! Again, insult to your loins right here. It says, write the equation of the tangent and the normal line. Come on! And what is the value of x? 1. Okay, let's get the point first. When x is 1, how do I figure out the y coordinate? Plug it in and you get the 2. Okay. That didn't sound like me, but that's fine.
Oh, I didn't know you caught someone.
Okay, now to compute the slope of the tangent line, now we need the derivative. Okay, who's doing this? Hirano?
Secant squared of 5/4 times 5/4.
That's what I want. Secant
stop
squared
right.
box times the derivative of box. Now, from this day forward, if you do not multiply by the derivative of box, it's a fatal error. That's like not using the quotient rule when it's a quotient, not using the product rule when it's a product. No, I'm
It's like
serious.
using the chain
If you
rule.
don't multiply by derivative of box, that's a fatal error. Okay, so what is the slope at this point? You need to plug in 1 for x, okay? What happens when I plug in 1 for x there? You're going to get 2 times something times pi over 4. What is the something? Kanashiro?
2.
Huh?
Root 2. Never mind.
So what's the real answer?
Wait, is it secant squared of that?
Secant squared, plug in 1 there, pi over 4. So secant squared pi over 4.
Isn't it 2?
Yeah.
Yeah.
Oh.
Why? 2 is correct. So, How do you write the equation of the tangent line?
What's
Y minus 2 equals pi times x minus 1. How do you write the equation of the normal line? Y minus 2 equals negative, reciprocatize that, negative 1 over pi x minus 1.
Oh, easy.
Yeah, it
Don't
is.
lie.
Alternate.
And then 56H.
Doesn't alternate.
No thanks.
56H.
Always
That's
alternate.
Okay, 56H. We got y equals the square root of f squared of x plus g squared of x at x equal 2. Now, just like trig functions, write it like that. F of x quantity squared, g of x quantity squared, so you can clearly see you have box squared plus box squared inside the radical. Okay, so let's take the derivative. I see square root of box, or if you rather think about it as box to the 1/2. Angelo!
Is it half of, can I just see the function itself? 2 f of x. Oh, okay.
Oh no, wait, it could be. You're trying to impress me. Okay, continue.
Oh no.
You could be trying to impress me. Go, just go.
That's just what I wrote. 2 f of x times derivative of f of x.
Which is f prime.
Yeah, f prime. Plus 2g of x times g prime to the negative half.
Okay, no.
Oh,
For real, I thought you were gonna impress me.
no. That was a good.
Okay, look.
That was too
Angelo,
far.
this is what you're thinking. You're thinking this is like 1 box to the 1/2, right?
Yeah.
What's the derivative of box to the 1/2 power? 1/2 box, right? 1/2 box to the negative half
That's the derivative.
times the derivative of box. Now, you took the derivative of box correctly, but it goes over here. You know what I'm saying? So what do I see in the box? I see box squared plus box squared. How do I take the derivative of box squared? 2 box to the first times the derivative of box plus, and then how do I take the derivative of box squared? 2 box to the first times the derivative of box. But see, I let you go because I thought you were gonna just write this first to try and impress me. You understand what I'm saying?
Oh, darn.
Okay, that's okay. And then if you want to factor out a 2 here and cancel it with the 1/2, you can, but now you got to plug in 2. Everybody can plug in 2 and read it off the chart, right?
No. Yes.
Yes. You don't want to get it.
Okay, wait, time out. So since somebody brought up 56H, I'm going to ask somebody at random 56E. Okay, who am I going to call on whose last name starts with a T and rhymes with Pran?
Oh no.
Maybe turn his website up.
Okay, no, for real. Please, no, don't look at your paper. Look at me. What is the derivative of f of g of x? I'll give you a hint. This is the definition of the chain rule. This is the chain rule. Just regurgitating what I wrote on the board yesterday. The chain rule. Okay, now you can read it off your paper. I can see it's blank from here. That paper is blank.
I didn't do this
It's like
question.
where? It's like where?
I like the first half.
Okay, then what do you okay, let's say okay,
Stuck in
You're-
Turkish prison.
you're in a prison. This is your one chance to get out. I'm the guard. I'm gonna let you get out of prison if you can tell me the derivative of that. And because I taught it to you yesterday. We're in trouble.
Scratch figure. Just to check.
Tomorrow.
F prime
Ooh,
of g of x times by g prime of x.
there you go. That's the chain rule. You have to regurgitate.
Trevor got out. You just.
Oh yeah.
Not like you're
Take it out.
Okay, I can guarantee the next quiz, that's gonna be one of the problems.
Just straight.
You have, and it doesn't matter what kind of letters too, you know, here. What if I give it to you like this? H of f of x, is that gonna throw you off?
Yes.
Yes, actually, and you're gonna get thrown out. Hey, we're BC, that kind of thing doesn't throw us off. Okay, wait, let me call on somebody over there. Choi, what's the derivative of h of f of x?
H prime f of x
Uh-huh,
times f prime.
exactly. Boom. And then can I trust you guys to plug in too?
Yes.
See, the difference between BC and AB, BC, yeah, we got it. AB, how many times I have to quiz them, because some of them put plus.
Huh?
Yeah. It's
Wait,
like,
whoa.
no, for real, they do. They put plus,
Divide
this,
by.
they put prime there. They do crazy things, but BC, we just know, right? The capital of Montana is Helena. Okay, the capital of Vermont is Montpelier. What's that?
What's the capital of Nepal?
Whoa! Stop right.
What's the capital of India?
New Delhi,
What, Thailand?
Bangkok.
Oh.
Okay, I'm 3 for 3. Any other questions?
Yeah, wait. Capital of Bangladesh.
Dhaka.
Turkey.
Wait, I'm so good.
Armenia.
I'm 5 for 5.
Thank you, Mr. Park.
I'll just stop at 5 for 5.
Ericlandia.
What?
Ericlandia.
Bosnia.
That's not a country.
It's a micro country.
Vatican City.
Okay, all the capitals I memorized for is when I was in high school. So like Armenia, that wasn't a country back then, right? Because the Soviet Union broke up, right? So Armenia, that doesn't mean anything to me.
What about
Slovakia.
It's that same thing too. Slovakia was just part of USSR.
Okay, South Africa.
What?
Cote d'Ivoire?
Cote d'Ivoire, that's Ivory Coast, Abidjan. But they changed the capital to Yamoussoukro.
That's on camera.
Stop right.
Wait, am I right? Am I right?
Yes.
Don't ask questions you don't know the answers to.
Wait, that we added
Asking questions.
Sorry, write it on the board.
Is that
Yeah,
I need to know if I'm right.
Wait.
Wait,
What
what
is
was
Cote d'Ivoire. C-O-T-E-D apostrophe Ivoire. I-V-O-I-R-E.
Just sound it out.
Wait, the
Dude, I got you.
Please.
Yamoussoukro.
Thank you. Yamoussoukro.
Okay.
Yeah, Yamoussoukro.
Wait, do you actually know all of them?
I used to, but I'm getting old.
Every day.
Was
That's
there a reason
good.
why you had to?
Just for funsies.
Oh.
For funsies?
Study in India, so it's different from.
Hey, come on. You guys want to get your test back? We're gonna do
Capital
this.
of holy territory.
What?
26.
Oh no.
Okay, today we're gonna learn implicit differentiation. Now, all the derivatives that we know how to take now, notice that y was given as a function of x, like y equals sine of x squared, right? See how y is given as a function of x? So when you take the derivative, you go, oh, sine box. So cosine box times the derivative of box, right? But what if you cannot solve for y as a function of x? What if the function is given implicitly? Let me give you an example. Oh, this is a good one too. I'm going to ask you a PCH question. X squared plus xy plus y squared equals, well, give me a number. No.
1.
Pi.
36.
No, wrong, 7. Answer 7. Okay, before we go on, this is PCH now. Everybody here took PCH. Yoshida, if I were to graph this, what is the graph going to be?
Ooh, is it a circle? No.
No.
Wait, that's not.
Moriguchi.
Is it-
Yes, it's an ellipse. Very good. How did you know?
is it the X?
Say with confidence.
X squared plus y squared, and
Yes.
then
Yes, correct.
Okay, at least you were in the right family. It was conic section. Remember when we studied conic sections in PCH? When you have the A
Oh, you
x
look at the
squared
E thing.
plus
right?
C x
F
plus
centricity
C.
or whatever.
Remember, you have to. Remember in the test you have to identify the conic.
Eccentricity.
B squared minus 4AC will identify what the conic is. So in this problem, you got 1, 1, and 1. So 1 squared minus 4 times 1 times 1. What does that come out to?
Negative.
Negative. So if it comes out negative, it's an ellipse. Positive,
Circle.
hyperbola. Zero,
Circle.
parabola.
That's interesting.
Really?
Okay, so you don't really have to know that, but I'm trying to get you guys
Okay.
to like remember things. Because when you go to college, don't you want to impress your like your what do you call the person that rooms with you? Your roommate. Yes. In fact,
Yeah, he knows
you guys graphed this in PCH. Remember the ellipse was tilted? Does that sound familiar?
That was on our test.
It was.
Okay, whatever. Okay,
We
anyway.
don't
So,
have to take tests.
is it difficult? Is it difficult to solve for y? Yes, it's very difficult. You would have to use the quadratic formula to solve for y. So, if you have an equation where it's difficult or even impossible to solve for y, we're going to use implicit differentiation. Okay, so watch what I do. This is just a technique now. What I'm going to do is I'm going to take the derivative of both sides of this equation with respect to x. Okay? What's the derivative of this with respect to x? 2x. That's easy, right? Plus, now I'm going to take the derivative of this term here with respect to x. Now notice that it's a product. We're going to use the product rule. Derivative of the first one, 1. Leave the second one alone. Plus, leave the first one alone. Now what is the derivative of y with respect to x? Very good. See, that's the difference between BC and AB. AB, you know what they say? They say 1. No, you're taking the derivative with respect to x, so that's why it's dy dx. Okay, now here, you gotta think of this as box squared. What's the derivative of box squared? 2 box to the first times the derivative of box. dy dx. That's right. Equals, what's the derivative of 7? 0.
Change it.
Now, this is the most important step when you're doing implicit differentiation. So if you want me to dumb it down for you, whenever you take the derivative of x, you get 1. When you take the derivative of y, you get dy dx. So you can also think of this as box squared, except so you go 2 box to the first, but then when you times it by the derivative of box, that's just 1. But then when you do it here, the derivative of box is dy dx. You guys get it? This is just a technique now. So how do I compute dy dx? Yeah, now you do algebra 1. There's 2 terms with dy dx in it. Throw it on one side. Like a wanted pet.
Change it.
Then you move these other 2 terms to the other side. You get negative 2x minus y. See how I did algebra 1? I'm trying to solve for dy dx. Factor out the dy dx. It's just a technique, people. Don't be scared.
What's going on?
And then finally, what do you think?
Same.
Divide. So dy dx is equal to negative 2x minus y all over x plus 2y. Cancel out the x's, cancel out the y's, so you get negative 2 minus over plus.
Yeah.
Now, the negative times a negative is a positive. I'm glad you're laughing.
But the
Because
denominator
AB,
is
no,
actually
in AB they'll just be taking the notes. Oh, that's weird, but there, that's dy dx. Now, see how when y is given as a function of x, the derivative only has x's in it, but when you take it implicitly, notice how you have x's and y's in it? Okay, now, so what kind of questions? Yeah, questions?
Because that's not a function.
Yeah, because, yeah, exactly. It's not a function. That's not a function.
I know
So,
some.
look at that thing. Now, what kind of questions can they ask you? Well, at the point 2, 1, write the equation of the tangent line. They're always going to ask you that question. So, what do you need to write an equation of a tangent line? You need a point. Now you need the slope. Well, what tells you the slope? The derivative. But since it's in terms of x and y, you not only have to know the x coordinate, you also have to know the y coordinate. Plug it in, and you got negative 2 times 2 minus 1 all over 2 plus 2 times 1, which is equal to negative 5 over 4.
Oh.
So point slope of the tangent, y minus 1 equal negative 5/4 times x minus 2. And I'm not going to insult your intelligence by asking you to write the equation of the normal line.
I think you should insult.
Forfeits.
Negative reciprocal.
Okay, I'll do it. Y minus 1 equal forfeits x minus 2.
AB might watch this, you never know.
Okay, now, no, they have their own video. But I don't make fun of them in that one.
What if they watch
Do you
this
make
on
fun
the-
of us?
Of course not.
Is it gonna stay next
Only
year?
it's a
You mean in the
multi.
multivariable calculus class?
Yeah.
Of course not. Okay, now what other questions are they gonna ask you on tonight's homework and on the quiz and on the test and on the AP exam? Find the points on this graph where the tangent line is horizontal. So you can clearly see there's 2 points on there. So
Number line.
how do I figure out where
Wait,
the
what?
tangent line is horizontal? Well, what's the slope of a horizontal line?
0.
0. So we want to know where on this graph is the slope 0? Well, here is the slope right here. Look at it. What would make this 0? The numerator is 0 or the denominator is 0?
Numerator.
The numerator is 0. So what you do is you take the numerator and you make it equal to 0.
Change it.
Now, what do I do with that? We're
Box
trying
it.
to find the points on this graph. In fact, you know what? I think I'm doing one of your homework problems for you.
Substitution.
Exactly. Solve for one of the variables in this equation, y equals negative 2x. Take that and plug it into the equation. Let's do it. X squared plus xy, but what is y equal to? Negative 2x plus y squared equals 7. In fact, I think I'm doing the exact same problem from the homework. X squared minus 2x squared plus 4x squared equals 7.
Oh.
3x squared, yes, I'm doing the same problem as the homework. X squared equals 7/3, so therefore x equals plus or minus root 7/3.
-2.
So there's 2 places on the graph where the slope is 0. That makes sense because it's a tilted ellipse.
Gotta check.
Oh,
check.
So once I find the x coordinates plus root 7/3, negative root 7/3, what's the fastest way to get the y coordinates? Should I plug it into this ugly thing?
Yes.
Or no? Or should I plug it into that nice thing?
Oh, they got an X squared there,
Matrix.
so it's.
Why you want to do that though?
Heavy
Why?
side.
The y coordinate is simply negative 2 times the x coordinate. Simply multiply that by negative 2.
Yes.
Multiply that by negative 2, and there you go. Those are the 2 points where the tangent line is horizontal. And you can probably guess now, what are the, find the points where the tangent line is vertical.
No.
So that would be like there
Graphic.
and there. Now, what is the slope of a vertical line?
Zoom.
Undefined. So, here's the derivative. What would make this undefined? When the denominator is 0. Now, I'm not going to do this for you, but you would just set the denominator equal to 0, solve for one of the variables, it doesn't matter which one, and you plug it back into the original. Okay, so,
Two arrows.
Lameshari, the most important part of this is to get this derivative correct. So, I'm just going to do a couple examples and then talk about that. Okay, let's do some trig. This trig is always good.
Yeah.
Okay, so I'm trying to concentrate here. Y cubed is equal to cosine of x over y. That looks so familiar because I probably put that on the quiz every year. Compute dy dx. Now, is it difficult to solve for y? Yeah, in fact, it's probably impossible. So we're going to do implicit differentiation. So just take the derivative of both sides with respect to x. Okay, so left side, I see box cubed. 3 box squared times the derivative of box. Now you can write dy dx or you can write y prime. To me, y prime is a lot faster. It's up to you. They mean the same. Now what do I see here? I see cosine box. What's the derivative of cosine box? Negative sine box times the derivative of the box. Now look at the box.
Oh, it's a
It's a quotient. I gotta use the quotient rule.
low the high.
Okay, low d high, which is 1, minus high d low, y prime, all over denominator squared we go. There you go, that's the most important step. And of course, can I trust your algebra to solve for y prime?
Probably not.
Okay, so if I were me, this is what I would do. I would multiply both sides by the LCD to get rid of the fractions. So you get 3y to the 4, y prime is equal to, and I would take this negative sign box and distributize it over there. So you're going to get negative y sine box plus xy prime sine box. Did I do that correctly? Now you have to put all the y primes on one side of the equation. So underline the terms that have y prime in it and put it on one side.
Change it.
No. It doesn't change.
It is not-
It is not the time for that.
Let's separate.
Now,
Reflect.
for those of you who are good at algebra, I wouldn't be surprised if you can just go from this step to the final answer already.
Oh god.
Okay, factor out the y prime. I'm trying to concentrate. Silence! I want to make mistakes. I already made enough.
I definitely straight.
And
Can go
then
from that to the
divide.
final.
Y prime is equal to negative y sine box all over 3y to the fourth minus x sine box. There you go. That's the derivative.
Code didn't make
This technique is called implicit differentiation. Okay, one more example.
Oh no.
Okay, let's do something with
All three of them.
shh. Oh!
Oh.
X squared plus y squared. Give me a square number.
One.
It's not
9.
one. Okay, 9.
Oh,
Compute. This is going to be on your homework as well.
That's a circle.
Thank you. If you want to solve for y, you could actually solve for y, but it's going to on the test it's going to say use implicit differentiation to find the first and the second derivative. Okay, so we're going to do implicit differentiation. Box squared. 2 box to the first times the derivative of box. 1. Good. Box squared. 2 box to the first times the derivative of box.
Y prime.
Y prime. Good. Derivative of 9? 0. 2y prime is equal to negative 2x. Y prime is equal to negative 2x over 2y. Now see, this, I give this problem to AB every year. You know what they do? They don't cancel out the 2's before they go on to the next step.
All hell breaks
What?
loose.
Just cancel out the 2's. It's a lot easier. Make the problem nicer. Okay, that's the first derivative. Now we do second derivative. So, again, we're going to take the derivative of both sides. So the derivative of the first derivative is second derivative. Now, what do I see here? I see a quotient. I'm going to use the quotient rule. Now, what do you want to do with this negative sign? You want to put it with the top, you want to put it with the bottom, or just put it in the front?
Throw it on the side.
Okay, it doesn't matter. It's up to you.
Like
Okay, let's throw it on the side. Now I see a quotient. So here we go. Low,
Low, D
D
high.
high,
One.
1, minus high,
D low.
D low,
One.
Y prime.
y prime. When you take the derivative of y, you get y prime. What's
AB.
right there? All over denominator squared we go.
Y squared.
Good job, Trent.
Okay, but Mr. Park, there's a y prime in there. What am I going to do with that? What do you think? What do you think?
blend in.
Exactly. What can I substitute for y prime?
Oh, right there.
Yeah, right there, the previous thing. Negative x over y, all over y squared. Now watch, this simplifying is going to be so good. It's going to blow your mind.
Elegant.
Watch this. No, it's not elegant, it's just nice. So negative
Oh,
y plus x squared over y squared. What's the fastest way to simplify that?
Common denominator.
Multiply top and bottom by y. So you're going to get negative, I should put this negative in the middle, y squared plus x squared all over y cubed. So your final answer going to be
Lift and separate.
negative 9 over y cubed.
Oh.
What?
Oh, yeah.
Where did that 9 come from?
oh,
Oh!
Oh.
X squared plus y squared is 9.
Wow.
That's beautiful.
That's
That's elegant.
That's
Brings
pretty.
tears to my eyes.
Alright, let me pass on the test.
need eye drop.
Okay, now, since I didn't have time to grade the last homework, what was the last homework on chapter 2? Limits. Everybody got 100% on that.
Like always.